is Jerre van Veluw. I'm a software engineer at Flow Community and I implement business rules for clients. And I think if you're producing code at a company, then hopefully that's what you do. If not, then hopefully you're then making frameworks or other things helping teams implementing business rules. So it's all about the business and the rules around that. And the implementation, yes. So the agenda for today is first a small introduction into several topics. We'll just scratch the surface a little bit, but those are the concepts that I will be talking about. And then the rest, the biggest part, will be about the implementation. First, I want to talk a little bit about domain-driven design because it's codifying your domain. And the hype is, or what everybody wants to do, is domain-driven design. Then a little definition what functional programming is, because some of these concepts return from functional programming. Then a little bit introduction in hexagonal architecture, because that fits really well with domain-driven design, or at least I think so. And then that's all nice, but that's just concepts. So in the end, I want to talk, or in the end, the most part, the bulk of the talk will be about actually implementing it in Kotlin, and I will just show you a lot of code. And it's about how you can code the model, the adapter, some errors, some logic, business logic, and that's all domain. And then how you can wire it up in an app, and maybe how you can interact with that app. And hopefully that will make sense in the end. If there are any questions, you can either ask them at the end, or if there's a really pressing question because you don't understand anything, or I need to speed up or something, or slow down, then please interrupt me. So first, domain-driven design. Okay, what is a domain? Now I have some definitions. These come from the person that actually invented domain-driven design, or the big blue book, as it's also called. And I found a PDF online where he stated basically this. So I'm just going to read it, and then I'll take out what I think is important. So a domain is a sphere of knowledge, influence, or activity. The subject area to which the user applies a program is the domain of the software. Maybe, I don't know really what this means, but I think I know what it's about a little bit. But I really like the sphere of knowledge, influence, or activity. So it's some sphere that you, well, it's about that thing. Then there is a model. That's a system of abstractions that describes selected aspects of a domain and can be used to solve problems related to that domain. Okay, nice. So there is something inside that domain, or an abstraction on that domain that we need to work with. Well, abstractions we know, of course, as software engineers. So the model is not just the data, but it's all the abstractions that describe selected aspects of a domain. Still a little bit vague, but maybe there are some hooks in your mind that you say, okay, I kind of think what is meant by this. Then a really important one, I think, ubiquitous language, which is a language structured around the domain model and used by all team members within a bounded context to connect all the activities of the team with the software. Okay, still, just let this sink in a little bit, I guess. But the ubiquitous language is then a language understood by all team members. And if you're in a team with business and software engineers and testers or whatever, then the domain and the model of the domain should be in a language that everyone understands. Or at least that's what I think the ubiquitous language is. Then there is some context. And that's a setting in which a word or statement appears that determines its meaning. And statements about the model can only be understood in a context. So there is no domain, there's no model that just lives as itself. There's always some context that gives meaning to the thing inside. And that's a broader context. And then there is a bounded context, where a description of a boundary, typically a subsystem or the work of a particular team, within which a particular model is defined and applicable. So maybe that's a smaller context. Well, these are just the definitions about domain-driven design. Still don't really know what is going on because these are concepts. These are maybe a little bit more vague or a little bit too abstract. But let's see where we get it and how we maybe can display this in code. But I think it's good to at least learn about the definitions that the person describing it actually said. Then something about functional programming. So I think that domain-driven design and hexagonal architecture and software in general can be really well modeled with functional programming as opposed to object-oriented programming. Because functional programming, this is just from Wikipedia, of course, because that's where I get my knowledge. Functional programming is a programming paradigm where programs are constructed by applying and composing functions, and it's a declarative programming paradigm in which function definitions are trees of expressions that map values to other values. So what is functional programming? It's a declarative programming style, and it maps values to other values. Of course, there's a lot more to say about functional programming, but for all intents and purposes, this is what the essence is, I think. So, hexagonal architecture. This is it. Nice, huh? So, hexagonal architecture is depicted as a hexagon. And that is your program, your application, in which your domain, and here I depicted this as this sphere, lives. And everything in your application, in your hexagon, actually depends on the domain through adapters. So this is also known as ports and adapters. Meaning that everything you do in your application, which is within that hexagon, has an adapter depending on the domain. So the domain doesn't depend on anything else than its domain, than itself. And of course, if you want to program your domain, it will depend on the language that you program your domain in or some essential libraries. But not on DTOs or other things. Then on one hand, you can talk about an API, application programming interface, because the outside world, of course, needs to interact with this program because, there is no such thing as just a program living on itself. And especially if you take it to the business, and when you're implementing business rules, then there is some information coming in, and there's maybe some information going out. And then you get some information from downstream services, and you provide back some information. So the API is where the user basically interacts with, and the SPI are the service provider interfaces. Those are all the services that provide you with data or other structures. Now note that it's a hexagon, so there's place for more than just one or two adapters. And of course, it doesn't necessarily have to be 6, but there are also, on the side, there are also adapters. So it doesn't really matter if you depict this as a pipe or as a function where input and output is just the two things going in and out. You can also think out maybe you want to model something with a queue. Is that a service provider interface? Is that an API? Maybe it's something else, but that's of course possible. But for all intents and purposes right now, most of the time I think we think about the API where you can interact with and you provide your API to other people, and the SPI is where you get your data from. And how would you implement this? So this is a concept about the implementation. Normally in a Spring Boot kind of programming style that we all probably know, or a model view controller style, you could say, okay, I have my controller or REST controller on the API side. That is my adapter into the domain. Then on the SPI side, we have adapters and repositories that have REST clients to the outside world and where you get data from. But those adapters also depend on the domain. And normally, of course, you would say, okay, I have my service, which would be, in this case, inside the domain, and I call my downstream client. But then your domain would actually depend on the adapter. So we're going to see how we can invert that. My colleagues at ING already know this, but we actually have, for instance, our language to the API side of the world. We talk about produce and consume. We produce our DTOs to the outside world, and we consume input from the user there. And internalize, externalize is for the SPIs. So we externalize data to be shipped downstream. We externalize that, and we internalize the stuff that we get back. Why are we doing this? Because then you can immediately say, I am producing this data. So you know exactly what part of the hexagon you're talking about. Maybe this is as part of the ubiquitous language where you can say, where even a PO or people from the business can say, yes, we are indeed consuming data, externalizing it there, internalize it from downstream and producing it again. If we all know that, then we also know what part we are talking about. And then, of course, what is the nice thing about hexagons? They stack. And you can tile a plane with this. So note here that maybe this controller interacts with this adapter. And here, I don't know. So this is why it's a dotted line. And of course, it can be an insulator that no data is going over that. But I thought just conceptually, as a mental model, it is nice that you can see the service mesh at your organization in this way. So you can all play. So what's this game? Kolonisten. Is that I don't know what the English word is. But Catan. Yes, it's just Catan. Okay, it's just Catan. Settlers of Catan. There you go. So you can play it like a game.
Yeah, but we're not allowed to say Kolonisten part anymore.
Ah,
yeah.
So Catan.
It's just Catan.
But it tiles nicely and for your service mesh. I think is at least for me the mental picture. But of course you can say, well, nice pics, dude. But where's the code? It's indeed codifying your domain and not just conceptually philosophizing about your domain. So let's dive into that, and that is indeed then the main part of this talk. So it's all about this domain. So let's codify that. And how I have created at the Flock GitHub a repository called Pragmatic, where I included all these things, so you can also look it up and actually see whether or not it works, or if something's wrong, then just add a pull request maybe. And I wanted to also follow the definition. So there is some model inside some user domain. So let's look at the domain model. And naively, and I will do this all in Kotlin, by the way, which is a really nice language where that tailors to the business needs, I would say. And where functions are first-class citizens, you have data classes and all kinds of nice constructs. So let's model this in Kotlin, and let's create a data class. And we'll model a user because we're in the user domain for, I don't know, some login stuff or a profile, doesn't really matter. And let's just first naively model this. So we have a data class. This user has an ID. It has a first name, a last name, and a birthday. And naively, I think we would all model it somewhat like, okay, an ID is a UUID or an integer or a string or whatever. Then first name, last name, obviously a string, because I don't know what these first names and last names are. Birthday could be a string. Maybe type it already a little bit strictly. It's a local date. But maybe when there is a request coming in through the API, the ID does not exist yet. So we could make this ID, this UUID, nullable. But then when you actually get this user back from the API and produce it, you always have an ID. So maybe we can model it like this. With a sealed interface, for instance, ID. And then there are two options. So this is a sealed hierarchy. It can either be valid or non-existing. And when the idea is when it comes in, then there is a non-existing ID. But when you produce it, you have a valid ID always. And this is one of the ways you can actually make this the problem space, if you will, about the user smaller. Because now it cannot be any UUID. No, you can actually differentiate between incoming and outgoing requests. And this can be done with value classes, for instance. These are inline classes on the AVM. And in Kotlin, you state it as a value class. And for now, you still need to annotate it with @jvm inline to make it indeed an inline class on the JVM. And what this does is actually wrapping it in this valid object. But on the JVM, this is compiled away, and it will be just the UUID. So you don't have the overhead of adding an extra object, but it will just reference this UUID. Now, nice thing is, of course, if you consider making all of these things in value classes, you could also say, well, I want to make sure that all the values that I have are generic. So I create an interface value for a generic type that extends any, so it cannot be null. And then you can add, for instance, a component one operator or an invoke operator, and then you can actually destructure this value or just use brackets to actually get this value out. So by defining this as a value, you actually have a target for extension functions to interact with that value, which may come in handy later. But of course we can do more, because a first name is a string, but if we have these value classes, why not just model it as a first name? Because if these first name and last name is a string, you can actually put the string that was meant to be a last name into first name and vice versa. So maybe that's not the best way to model this. So let's create indeed a first name and last name, but also let's do that for birthday. So I think what is nice about really thinking about your domain is that you can in the end just state, I want my first name to actually be a first name, my last name to actually be a last name, and my birthday to actually be a birthday. Whatever that may mean. And then because when the API call comes in, you don't have an ID yet, you can define an operator function invoke, where you just invoke this object with just the first name, last name, and birthday. By the way, I tried this with the secondary constructor, but that didn't work because of the generic ID. But this is also a pattern that I will be using more. So this is also why it's up here. Okay, so let's look at this first name. And let's just make it a value class. And that is the simplest version with using this value is shown here. So a value class just has one field. I've named it here value, but you can name it anything. And on the JVM, you have to add this JVM inline. But if you make this a private constructor, and again add this operator fun invoke, then you can actually return something else than what the constructor can do. Because normally, when you have a constructor on first name, and you call that constructor, you get the first name. Because you're constructing first name. But the invoke function doesn't necessarily need to return a first name. So you can actually wrap this invoke function, or no, not wrap this invoke function, you can actually use an either construct here. So this invoke function now returns an either. That means that, and this is then the syntax, so there is this either function here, with curly brace open. And then you can access this ensure function. And then you can state ensure that the string is not blank. And then return the first name and construct it with this string that was indeed not blank, because otherwise it wouldn't end up here. And then maybe also trim that string so that you lose some white space around it. But if it is blank, then you can just have this function here. And that's where we encounter our first error. And you can model that later. And you can call that first name error.empty, for instance. So there is some object with .empty there. So that means that this construct returns either with on the left-hand side a first name error.empty, and on the right-hand side a first name. So it's either an error or a first name. And that's of course really nice because then you can validate your domain exactly where you define your domain. Meaning that if your user has a first name, you are sure that this string that is in that wrapped first name constructor is not blank and is trimmed. And of course you can do the same thing with last name, and you can model it in the same way. You can even then say, okay, I have this last name error.empty, and then again you return an either. I will show you later how you can deal with these eithers when you're actually going to construct this user data class, because that of course will be quite tricky because you have to deal with all these eithers. And this use of either is something you see in functional programming as well, because this is also mapping these functions and using this either construct. There are also other ways of constructing this. For instance, birthday, we know that we want to model it as a local date inside this value class. So there is this either.catch, where you can parse this local date into a local date. And if this fails, then there will be some exception in that left-hand side. And then you can map left that to some error, because you don't want to deal with exceptions. I will come to that as well. And then just map it to the birthday. And because it's a private constructor, this also yields an either with on the left-hand side an invalid birthday error, or on the right-hand side a birthday. And of course, you can go crazy with all kinds of validators in between. So that was the model. And then, of course, we need to look at the adapters. And in the domain, you can actually model these adapters like this, like interfaces. Because an adapter, if you want to model it inside your domain, I think it's basically, or how I view it, if you state your interface user repositories in the context of your domain, then you're basically giving some downstream object an API to implement. So we can define this user repository in our domain module, our Maven module, and we can just do all the basic CRUD operations like get all, get by ID, save, delete by ID. And then you can indeed see that if you want to save a user, then it has this ID non-existing. And when it returns, it has an ID valid. And in this way, your compiler can actually help you checking whether or not this is true. And in this way, it reduces your problem space that you have to deal with. And then, of course, delete by ID and get by ID, you can only do with a valid ID. So that is also helpful so if you, for whatever reason, tried to get a user by ID with a non-existing ID, you don't find out in runtime, but you already find out at compile time that this will never be able to work. And that is, of course, the power of actually defining your domain in terms of these types.
Would you not want to have an existing ID at this point? So that might be domain-based as well?
Yeah, so in save, you don't need to have an ID, but if you return from your repository, you need to have a valid ID.
Yeah, that's what I mean. Like, maybe by now you want to have some kind of ID in place, right? Because that might be domain logic, company logic. They want their IDs shaped in a certain place. And that's now left up to the repository, right?
Yes.
Yeah. It feels like a responsibility that maybe shouldn't be there.
So in this case it is,
yeah,
by definition. And then you could argue whether or not you want that. And I would argue that you can do this in the live implementation of your live user repository, or maybe you even want to do this in your database. But then again, when it comes back and goes into your domain, you will have a valid...
Also, yeah.
Sorry?
When it comes back, it should definitely be there. Yeah.
Yes, yes. But what you could also do is say, okay, no, I want to have this either, because maybe if something comes back, it could go wrong. So let's already model it like such. And this already looks a little bit more like functional programming because you're using an either. Well, it is really nice. And if you are really into functional programming, you might want to wrap this in an IO or a ZO or whatever. In Kotlin, we don't have that. But in Kotlin, we have suspend. And according to the guys at Arrow, and Arrow is actually the library that provides us with this either, which is a functional compendium to Kotlin. They actually equate this suspend fun. So this is coroutines. So these are async functions. These functions can actually be suspended. They equate that with an IO. So for all intents and purposes, of course there is more detail to be said, but for all intents and purposes, a suspended function you could view as the IO or the lazy evaluation of your program. And this is what makes it then declarative and functional. Another trick that's really nice to use is actually if you declare here as well an interface called has user repository that returns a user repository just from one value, then you can actually in the end compose these different repositories. So maybe you have a user repository, maybe you have a to-do repository, but your to-do repository also has a get all, get by ID, save and delete by ID. And then to namespace that a little bit, you can use this pattern, which is a module pattern. And then you can say, no, I want to have my user repository.getAll or my to-do repository.getAll. And I'll come back to where you can use this. I've already shown you an error in the either. Of course, you have to model that. And these errors, I think, are part of your domain. So you don't only model your happy flow, but you also model your unhappy flow. So if you then look at an error, you can actually model this like a sealed interface as well, because then in your error handling, you can just, with the when statement, you can handle all different errors. So let's just define it as a sealed interface error with just one thing. It has a message of type string. Of course, you can also model this as a message. But yeah, you of course also have to see how far you want to go with all these type things. And in the end, a message is a string. And then, for example, you can have domain errors or validation errors. And then maybe a single validation error or maybe multiple validation errors. And then if you want to have specific validation errors, for instance for user, then you can define them in some other class and they will also be part of the sealed hierarchy if they are in the same compilation unit. So this is a way to model that. But of course, if you provide an API on your interfaces, for instance on your repository on an adapter, where something goes technically just wrong, like a timeout or a connection or something else, a library that throws an error, you might also want to capture that. So these are all the known interfaces, all your domain, all your known errors. But maybe there is also some unknown thing that is a throwable that you have. So it's also nice to have a technical error with actually a cause, and which is a throwable or an exception or a runtime exception, just how you want to model it. And that can then indeed also extend runtime exception. And why do you only want to extend runtime exception here and not everywhere? Because you don't want to throw errors in a functional programming paradigm. You just want to capture that in an either. But if you have a cause that is of type throwable, you might want to have a stack trace. And then you can indeed use runtime exception to actually fill that stack trace. So in this way, you can indeed, when something happens that goes wrong that you don't know about, which happens in some non-functional library, you can still have this stack trace and check out where it went wrong. But it is still also part of your sealed hierarchy with this error. Now then we have already had the model and the adapters, and now we can go on to the logic. So the meat of your program, of course, is your service. Or if you're working with Spring Boot, then it's a service. And those are the business rules of your domain, the business rules that you are actually implementing. And to show that you don't have business rules, you can write it like this. There is some function, get users, and that means that you want to go to the user repository and say get all. If you want to have a filter or a map or aggregate or go to a to-do repository and aggregate the data, you can all do here. So this is a placeholder for your business logic. And the nice thing is if you do this and you find out that you don't have any business logic, then you might get rid of it as well. Now, of course, this user repository is something that you need to access, needs to come from somewhere. So what you can do is actually collect this in a static object. So these are just top-level functions. You can wrap it in a user service object just to do some code organization and make people reference this service thing so that they know where to look. But then here is this context thing of domain-driven design. This only works in some context. And from that context, you need to get your user repository or to-do repository, and then you can interact with it. So how can we define this user context? Well, it's just an interface. And here you can see that this model pattern can kick in. It has a user repository. So by using these interfaces and this module pattern, you can actually compose the user context with these has user repository, has to-do repository, has whatever adapter, has, I don't know, all kinds of things. So in that way, you can build up your context. And in this way, you can actually access your repositories or adapters. This is it. This is basically what codifying your domain is all about. But of course, we have three other structures because this domain that is now codified cannot interact yet. Everything is just a function and just an interface. So how can we wire this all up? So that is what is happening in the app, and that's also where the hexagon comes in, because these adapters need to be implemented somewhere. They need to be called somewhere. So let's, for instance, look at the user controller on the API side of the picture. And as you can see here as well, we're now in the app part of the module. So these four modules, by the way, are different Maven modules in this case, meaning that the domain part is compiled first, because everything else depends on the domain. And then within this app, you can still have this user thing that you're talking about. And then you can have a downstream live user repository. So that's where your implementation lives. That's where you can do your connection to the database, map it to an ID, stuff like that. And on the upstream side, on the API side, you have your user controller. And there you can just call your top-level functions in your user service. But how do we do that? Well, we can just, of course, in some controller create a function where this is a post, so an HTTP post with a post mapping. And there we can just use Spring. So I haven't talked about Spring yet, or any other framework, or at least not in the domain. But of course here you are free to choose your own framework. So let's use Spring. And then there is a potential user DTO coming in. And then you can map it, again in this either syntax. There is a potential user, and you consume that. So you map the potential user to the actual domain user. And then there is this bind operator, or this bind function, which only exists in the either scope that extracts this right-hand side of the either and puts it in this value user. But if it would go wrong, then it would actually go to the either scope to the left-hand side. So for your functional programming bodies, this is the monad comprehension or the either comprehension or the for comprehension for these constructs. So you're binding the right-hand side of this either that comes from this consume function into user. And then you can use that validated user to put it in save user, which comes from our domain. That returns an either, and then you can bind it to the same scope. So whenever it goes wrong on the potential user or on the saved user, it will be collected in this either, and then we can return that saved user and produce it to the outside world. And because that could also maybe go wrong, then this is all collected in this either, and then you can do some handle function that handles that. So how can you actually consume and produce these things? Because if you want to reason about all of your consumable objects or all of your producible objects, you might want to use an interface to handle that generically. So how can you do that? Well, you can just define an interface called producer or consumer that just has one function called produce and consume. And there are some generics here. So for instance, for the consumer, you can say, okay, a consumer means that you go from some external object to a domain object. And then you can actually implement it, again with this either, because if everything is an either, you need to be able to work with that. And then there is another function provided by Arrow, zip or accumulate, meaning that you can then quite succinctly or concisely construct this first name, last name, birthday that we have defined with just the strings. Like the first name comes from the potential user DTO, so from some request upstream. That's just a string. The last name is just a string. Birthday is just a string. And then we can use these operator invoke functions on these value classes that returns an either, and that we can bind to the either scope. And then when this all goes right, we get an either right, and then we have our user. Because remember that we have defined this invoke function on user as well, where you can just provide it with a first name, last name, and birthday type. And that's it. But if it goes wrong, then the nice thing of this zip or accumulate is that it does not short circuit with the first name being wrong. So if this first name is empty, then we get this first name empty error. But it actually continues. So this yields a validated user, which is an either list of validation error or user with a non-existing ID. And this is all typed, and this either compiles or it doesn't. Meaning that if you use this consume function, you always get a valid domain object or a list of validation errors. Meaning that if you have an empty first name, an empty last name, and some unparsable birthday string, you can give that feedback in a list of errors to the user. So you can just say, because otherwise you would say, oh, your first name is wrong. And then you go back with the right first name and say, oh, now your last name is wrong. That can be quite annoying. But in this case, you can say, okay, this is all wrong. And then, of course, the other way around, it's easier because you can just produce your valid domain into all these strings. And then here you can see this invoke extension function on value, because remember we extended all these value classes with value, string, value, UUID, value, and local date. And then you can just invoke that function like so. And because you can invoke that function, you get the string out of it. So you don't have to say first name dot value, which would also be valid, of course. And then you can format your birthday and stuff like that. And of course, the nice thing is here, if you change your domain or the DTOs change, you only have to change the mapping here at first. So you don't have to then refactor your whole code to do this. And then you can use it in your controller like such. And of course, you need to create your context. You can do it like this. You have this interface. You define it again as your controller dependencies, where you say it has a user repository. You can instantiate that in some bean. And of course, your user repository is implemented as a live user repository where you do all your wiring. And then you can inject it like this. Construct a context and use this context so that your domain actually can work within this context. And then there is some handle function. You can map your errors, whatever you want to do in your controller, like normal. Cool, then we're almost there. Of course, now we have a controller, we have our app wired up, we have our domain, but we need to interact with that somehow. These potential user DTOs and stuff like that need to come from somewhere. So that we could actually define in our API, and why not just actually define it as an API, as an interface. So in some other module, you can have your request and your response and your API. And then you can indeed actually create and define an API. And just to show, here in the user controller, you can then actually tightly couple your user API to your controller. Which is nice, because then you can actually write your API first in code, and then annotate this with these Swagger annotations so that you can also generate a Swagger JSON. So this would mean that you can, so the discussion about whether you want to write code first or spec first, you can say yes, because I write code and spec in the same time, because, well, either the one or the other is getting generated. And this reads, I think, way more easily and writes more easily. And this is then, for instance, the potential user detail where these things can all be strings. So it looks like a stringly typed API, but because you're validating this with your domain, which is actually decoupled from all your implementations, you maybe could provide your instance with locally implemented adapters and repositories, and just say, okay, if you want to know whether or not the strings that you send to my API actually works, then here is a local running copy of all my validators of the actual code. How can we generate then also a Swagger JSON with a Swagger Maven plugin? You can define it as such. It will take these structures of the Kotlin interfaces and also these annotations. And we can also do that on the SPI. So if you are, for instance, at ING or at another organization where you have all these Swagger JSONs, you can also do the reverse. So you can have, well, the famous or infamous pet store Swagger JSON. You can take that, configure an OpenAPI generator, and then for the specific thing, you can generate all these models, and then you can actually use them in your live API, your pet adapter. In this case, this is just an example where you can say, okay, I have some client, a REST template, and then I have my domain pet adapter here, just as the same pattern, and then I can say, okay, I want to get my pet by ID with some int. But then here, you have all these nice types, but here, you can just type some URL and then it will break because it wasn't that URL. I have to manually get here this external pet class that apparently I think I get back from this URL. And then I don't know whether or not I get the body or not, and what kind of errors do I have. I cannot do that by just using the models from OpenAPI spec. Second problem is, you can actually also generate a client with OpenAPI generator, but then you have to specify your language, but also your framework and your HTTP client. So you would say, okay, I want the Kotlin Spring OK HTTP generator. And that, of course, is a matrix of a 3D matrix with all, of course, if you now go to Java, but not Spring, but maybe, this is just a lot of things that you need to generate for all those options. So we're actually building WireSpec, which is a hobby project or a Flock project that Veluw and I are working on, that tries to solve this problem. So what is WireSpec? Well, it can also have just the same structure. Also with a plugin, you can actually just point to a pet store JSON. And then when you implement your pet adapter, you actually, I will show you how to build the pet store client. But then you actually can say, okay, not only the models are created as a pure function, but you actually get on this client a get pet by ID function. a get by ID request that you can fill with your int. And then you get back a sealed hierarchy of all the status codes and the objects that belong to precisely that status code. So here, I don't have to specify the URL because it's generated. I don't have to specify what body I get back. And it's already clear that this is a non-nullable body if I get a 200. And this is generated from the pet store, so you indeed can see, well, there is an application JSON response, but also application XML response if you want that. And there is a 400 bad request error that I get back, and a 404 not found, but apparently not the other things. And then I can just use my internalize function that internalizes this all in a valid domain. And for the save pet as well, there's a 405. And so I know based on the specification that these are the only possibilities. Okay, so how do we do that then? Because the philosophy of ISPEC is that you don't need to specify your framework and your client, so you have to provide it with a client and a mapper. So there is this YSPEC content mapper. You want to have some client, in this case a REST template. And then there are these interfaces generated, add pet, get pet by ID, find pets by status, and all the other things. If you then just compose them into a single pet store client interface, then you can say, okay, you just have to override these functions, create some handle function, and then this is where the magic happens. So this is indeed, of course, a little bit bigger, because then you have to map how to state the mapper, how to map a byte array to an object. But that is then, you just have to do once. And for instance, this is how you can do it. You can say, okay, I want to do this with an object mapper, and I just write it to an object or two bytes, so the read-write. And once you have done this, just once, then you can use that in all your clients, so for your pet store or for your user adapter or other things. That was for the SPI. You also can do it for the API. So YSPEC is actually a language. There is already a plugin on IntelliJ with this plug icon, which is, of course, really nice to show, and Willem is really happy with that. The extension is WS, and then you can actually define your API like this, which is maybe even easier to type than an interface with all these annotations, and definitely better than the whole Swagger JSON. And if you do this, you actually get the same generated content, because whether or not you parse this or an OpenAPI spec, it all compiles down to the same AST and then emitted in the same way. And that was it. So if you want to look this up somewhere, then there is this pragmatic on Flow Community and YSPEC at Flow Community. And if you want to know more about Arrow and these either and either comprehension and stuff like that, it's for Kotlin, it's the Arrow kt.io. And are there any questions?
I'm wondering, why do you have to use the invoke functions and can't you use secondary constructors in Kotlin?
You can, but then you need to return the thing that you're constructing. So an either cannot be returned by a constructor because you're constructing a first name. Now, I don't really know why it cannot be done with the user, because you're returning actually a user. And it is, but that was not possible because of the generic ID. So it was a little bit weird. And I thought, well, anyway, I'm using invoke functions anyway, so why not? And then you get the invert, the type will be inferred, and then it will be always a non-existing ID.
But is it a conscious choice to make then it look like you call a constructor instead of making constructor private and having another function that constructs your user and or the first name and have that either? Because it's different now, right?
Yes.
Because we all know the constructor will return the thing you construct.
Yes.
And now you deviate from that.
Yeah. Yeah, so it's a conscious decision because you still want to model the first name as a string, because in the end it's a string. but you, still you want to reduce that problem space of having a string that can have, well, maybe an endless problem space.
Yeah, I understand.
And then,
you could also say first name dot create instead of
you can,
method.
Yeah, so this is a conscious decision to do that because still you want to construct the first name also. You can also go for create, but then it would be indeed first name dot create and then having this Other questions? No? Then let's get some beers, I guess.